Alright, sort of continuing our theme here and dealing with fractions involving polynomials, we have this topic of complex fractions. Now, what is a complex fraction? A complex fraction is a fraction that has fractions within it. Or you could say it's a fraction of fractions. So the numerator and maybe the denominator as well, they can have fractions within them. And that can make it look a little complicated, hence the name complex fraction. What's the goal? The goal is ultimately just to simplify the expression into an ordinary type of fraction. So there's no little fractions lurking about. You just have an ordinary numerator with no fractions, ordinary denominator with no fractions, just an ordinary fraction. That's the idea, that's the goal. Now there are basically two types of problems, so let's just kind of outline the two types of problems here. Two types of problems. One type is really easy, and the other type, not so easy. So let's take a look at the easy type first. We'll write down examples of both here, and then we'll focus on the easy type first, and then we'll look at the second type. So here's an example of what I'll call the easy type, because it is relatively easy to do, as you'll see. I guess I'll take care of the colon there. Looks something like this. M to the fourth over R, all of that, over M squared over R squared. Okay, so you can see you've got a fraction on the numerator, fraction in the denominator, so fractions within fractions, that's the idea. But this is relatively easy to handle. Let me show you an example of the not so easy type, and you'll see it, yeah, it's a little more complicated, a little more going on there. Not so easy type. Now, not all these not so easy types are really difficult. They're not always that bad, but as a general principle, they take a little more thought to get through, a little more sophistication. Your approach has to be a little more thoughtful or sophisticated to make it work, to get through the problem, to simplify it. That's because, well, the situation's a little more complicated to deal with. Here's an example of what it might look like. As you look this over, I think you'll appreciate the fact that, yeah, there's something about this that makes it more complicated than that first one. Essentially what it is that you've got fractions being added or subtracted within the complex fraction. And that is an issue that has to be dealt with carefully, requiring a little more care or finesse to get through. And we'll definitely do that. There's definitely a straightforward approach, but it definitely requires a little more thinking, a little more sophistication than the easy type. So we'll start the easy type, play with some examples of that. You'll see that, hey, that's pretty easy to do. And then we'll move on to the not so easy type and show you that they're not always that bad, but they do take a little more care. And again, in either case, the goal is to take the complex fraction and simplify it to an ordinary fraction. So you'll no longer have little fractions lurking about in the expression. It'll just be an ordinary fraction. All right, we'll start the easy type. Let me erase this here. The thing to notice about the easy type is the format. So let me emphasize that here, the format of the easy type. Because the format is what basically tells us how to do the problem, what to do to simplify it. So the essential format of the easy type is just this. You have a fraction on top divided by a fraction down below. There's your format. That's the heart and soul of the matter, if you will, the structure of the problem. There we go. What does it mean? This is what it means. Think about this for just a second. Let me use a different color there. If I have a problem of this sort, we can easily handle it, because all it's telling you is take the top fraction divided by the bottom fraction. Let's write that down. Top fraction divided by the bottom fraction. Now, you know how to handle this. How do you take two fractions and divide them? You take the Second one, flip it over and multiply it, right? You multiply by the reciprocal of the second one. So just take the first one and multiply it by the reciprocal of the second one. That is how you handle the easy type, and that's why it's so easy to do, because it doesn't take much effort. In fact, you could skip the middleman if you want. You can go directly from here as your starting point and jump immediately to this point right here. You don't have to write that middle step there. In other words, all you got to do is take the fraction on top, write down, multiply by the reciprocal of the fraction down below, and there you are. You're ready to rock and roll. Do a little factoring and canceling if necessary. Put it in lowest terms. Voila, you're done. Hence, they're easy. That's why it's the easy type. All right, so let's try some examples. We'll start with this one here as our first example, illustrating how that works. In fact, I'll just leave it right there. I think we got enough room to do that. Make sure my board's still somewhat centered. It always gets off out of whack. Okay, so here we go. Let's go ahead and just work this example right here. Oh, in fact, there is an example. I'll have to say the word example again. There we go. So how do we handle it? We're going to do exactly what we were just talking about a second ago there. We're going to take that top piece, write it down, and the fourth over r, multiply by the reciprocal of the bottom piece. There it is. And then simplify. Cancel, whatever. Is it much to do here? No. You can think of using the rules of exponents if you want. M to the fourth on top, m squared down below. If you think of the quotient rule, 4 minus 2 is 2, you get m squared. On the r's, similar story. R squared on top, r down below. A little canceling there gives you just an r. And there you are. That's your answer. Not a whole lot to that. And most of your easy type problems don't take much effort. Let's run through a couple more of these guys just to reinforce this so you can see, yeah, these aren't too hard to do. So, guess we'll put that right there. Now, what's another example here? Let's see. Another example. 8x minus 24y. That's over 10, and all that stuff is going to be over x minus 3y over 5x. Alright, so again, this is an easy type complex fraction. You got one fraction divided by another fraction, so take the top one, write it down. There it is. Multiply by the reciprocal of the bottom, so put the 5x over x minus 3y. There you go. And then from there, it's the same story that we had earlier with the rational expressions. Factor, cancel, done. So if I do a little factoring here on top, that first numerator, take an 8 out as a GCF. There we go. All right. And a little bit of canceling going on here. You don't have to cancel everything at once. So for instance, maybe I'll just focus on canceling out the x minus 3y's, get those out of the way. I can multiply horizontally here. 8 times 5x would be 40x. 10, and that's all we have down below. And then 40x over 10, of course, is just 4x. Voila. Not too bad. Not too bad. Let's do one more of those. I think I just want to make sure you got these guys down cold because they're easy. Should have them down like the back of your hand in no time. How's my board doing here? Slightly crooked. All right. So one more of these guys, and then we'll move to the not so easy type. All right, so here's our next example of the easy type. There it is. Again, notice the format. One fraction on top divided by one fraction down below. That's the easy type format. It's got to have that format to approach it the way we're doing. But when it does, you'll know it. You can see, yeah, take the top fraction, then multiply it by the reciprocal of this guy. So flip it over, you get the k squared minus 25 on top over the 16k. Good. Do we have any factoring at all? Yeah. K squared minus 25. You probably recognize that, don't you? Difference of two squares. What do you square to get 25? Of course, a 5. So k plus 5, k minus 5 on that. It's pretty straightforward, I guess. Now, what can cancel on this? Well, of course, you've got the k plus 5s that are going to disappear. Anything else that might cancel? Yeah, you might as well go ahead and do it. It's pretty easy to do. That 4, the 16 leaving a 4 behind. Okay. So what's left behind? We have a k minus 5 left behind on top. And then down below, we've got a 4 and that k, it's still there. And there it is. And that's how you do the easy types. Like I said, not that challenging. I think I only gave you a few of these in the homework. I didn't want to give you too many because it doesn't take too much to get good at them. I wanted to reserve most of the examples for the not so easy type because those are the ones that are going to take a bit more practice to get good at. But there's the easy type. All right, so let's move on to the not so easy type. Since that is the stuff that takes more practice. And I think I'll go ahead and put those in the next video, just to begin the next video with the not so easy types. Keep this video a little shorter.